The most common type of system of linear equations is the consistent system. This will result in an ordered pair for an answer. But there are two other kinds of systems. One is inconsistent and the other is dependent, and both have their own specific way to express the answer. So let's look at an example of each one. We're going to solve the inconsistent system here, 3x plus 2y equals 2, and negative 6x minus 4y equals 8. Now we don't know that it's inconsistent, but just for the sake of this, I'm telling you what it is now. But how would you know? Well, first off is we need to solve this system to find out how it's going to become inconsistent. So I'm going to solve this by using elimination method, and I am going to eliminate x. So when I eliminate x, I'm going to multiply one or both equations by some constant to get rid of it. In this case, I'm going to multiply it by 2. But I'm not going to multiply the bottom equation by anything. I'm going to leave it as is. So when I distribute the 2 across, I'm going to get 6x plus 4y equals 4. And then I'm going to bring the bottom equation across, just as is. Negative 6x minus 4y equals 8. And now using the elimination method, I'm going to solve it. 6x plus a negative 6x is 0. 4y plus a negative 4y is 0. And then 4 plus 8 is 12. And 0 equals 12, which is obviously not true. So since I get a false statement or a contradiction of a statement, we can say that this has no solution, and we can say it's empty set like this. We could say just a set notation with nothing in it. You could even say that there is no solution. All these things mean the same thing, just whatever notation you prefer to use. I would just spell it out, but that's just me personally. Next is the dependent system we're going to solve for. So again, I'm going to look at this and I'm going to eliminate a variable because I like to use the elimination method. So I'm going to multiply the top equation by 2 to get rid of y. And so when I do that, I'm going to get 6x plus 2y equals 2. And I leave the bottom equation as it is. So negative 6x minus 2y equals negative 2. And so if I add these together, 6x's cancel out, the 2y's cancel out, leaving me with a 0, and then 2 and negative 2 give me a 0 as well. And 0 does equal 0. That is a true statement. So this is a dependent system or identity statement. So writing it's a little bit weird, but you use set builder notation, and we say that the order pair x, y is our answer such that, and you could pick either equation. I would just do the top equation. So we can say that 3x plus y equals 1, and then close bracket. And this would represent the answer for infinitely many solutions for a dependent system.